summarize it diagrammatically. A particle travels in a straight line with uniform acceleration. So the catchword there is uniform acceleration. So meaning you know that you're going to apply the uniform acceleration formula. He's traveling in a straight line with uniform acceleration. The particle passes through points A. So let's call this point A, point B, and then point C. In that order, at time t is equal to 0, 2, and 5 respectively. So at time is equal to t is equal to 0, t is equal to 2, and t when t is 5. So when the time is 0, when the time is 2 seconds, and the time is 5 seconds respectively. So if BC is 30 meters from here to here, it's 30 meters. If BC is 30 meters and the speed at B is 7 meters per second, so the speed at B, let's call it, find the velocity V is 7 meters per second. Find the acceleration of the particle and its speed when at A. So they want you to find the initial velocity here, and also that is the speed at A. Of course, the speed at A is the initial velocity. So they want you to find the initial velocity, and also they want you to find the acceleration of the particle. So they also want you to find the acceleration of the particle. Now, already in some part of our information, we've been told that between B and C, the object covers 30 meters. So we can use this to find our value of A, the acceleration. We know that we are going to get the expression for distance from A to C, subtract the expression for distance from A to B, because SC minus SB gives us 30 meters. So let's look at the distance covered at C. We shall call it the distance covered at C. SC is going to be given by, of course, we shall be using UT plus a half AT squared. We know that the distance covered after traveling up to C, initial velocity here, we do not know this, so we shall call it U times the time times value of t at C is 5, so U times 5 plus a half times the acceleration, which we do not know because we don't know it, times t squared times 5 squared. Of course, here we are going to end up with 5u plus a half times, this is 5 squared, is going to be 25a. So a half times 25a, so this is like 25a divided that by 2. So this is distance covered after reaching point C. So let's also get the distance covered at B. SB, distance covered at B, is going to be equal to still UT plus a half AT squared. The initial velocity, of course, it's not known, it's going to be U times T. The T at B is 2, so it's 2, U times 2 plus a half times the acceleration, which we still do not know, times time squared. The time is 2, at the point B time is 2, so it means that it's 2 squared. And so we shall end up with our SB as 2U plus 2A. So we have our expression for SB, we have our expression for SC, and we know that SC minus SB is giving us 30 meters. So we shall say that the distance covered after C minus the distance covered after B gives us 30 meters. So SC is going to be 5U plus 25 over 2 is 12.5A minus SB, which is 2U plus 2A, is going to give us 30 meters. And so we are going to get an expression in U and A. So this becomes 5U minus 2U is 3U. We have 3U plus 10.5A is equal to 30 meters. So it means that we need to look for another equation from our information that is going to help us to get the values of A and G so that we solve the two simultaneously. Looking at our question, The other information that we can take advantage of that can help us get the second equation is that we have this distance AB, and in this distance AB we are having the initial velocity not given, and then we have the final velocity here, 7. So if we use the first equation of motion, v is equal to u plus at, we know that our final velocity is 7, our initial velocity is not known, which we are supposed to be getting, and also our acceleration is not known, we are also supposed to be getting it. This simply means that we'll be getting a second equation that is having these two unknowns, and we shall be able to solve those two equations simultaneously so that we are able to get the value of a, which is the acceleration, and also the value of u, which is the initial velocity or the velocity at point A. So we'll go ahead and find that second equation. So getting ours, we know that v is going to be equal to u plus at. And we know that our final velocity, if you are to consider motion from A to B only, it means if the particles traveling from A to B, B would be the final velocity, which is 7, is going to be equal to the initial velocity u, which is the velocity at A, which we do not know, plus the acceleration, which we do not know, times A, and then multiply that by the time it takes to move from A to B. The time is 2 seconds, which is times 2. So we end up with 7 being equal to u plus 2a. So we have our second equation. Our first equation was this one. So it means that from these two equations, we solve them simultaneously and get the value of a. Of course, we make u the subject of the formula here, and we substitute the u into there. So if we make u the subject of the formula here, you'll find that u will be equal to 7 minus 2a. So we substitute for this value of u and put it right here, and when we put it right there, we're able to get the value of u, and then finally the value of a. So right here, if we are to put it in there, it will become 3 times u. Now the value of u is this one here, so 3 times u, which is 7 minus 2a, plus 10.5a is going to be equal to 30. So definitely this is 21 minus 6a plus 10.5a, giving us 30. Negative 6 plus 10.5a is going to give us 4.5a, is going to give us 30 minus 21, giving us 9. Then our value of a definitely there is 2 meters per second squared. So after getting our value of a as 2 meters per second squared, we can go ahead and substitute for the value of a here so that we're able to get u. So when we substitute our value of a there to get the value of u, we shall end up getting our value of u being equal to 7 minus 2a. 7 minus 2a, a is 2, so 2 times 2, giving us 7 minus 4, and we have our value of u as 3 meters per second. So in so doing, we are able to we will have finished solving the whole question. The question is asking us to find the acceleration of the particle and its speed when at a. So we are able to find the acceleration of the particle, which was 2 meters per second squared, and its speed at a, which so happens to be the value of u, the initial speed, which was u, which we got at 3 meters per second.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia, helping you manifest excellence.